The other major thing that you can do to minimize the time that your program spends in its memory accesses is what's called coalescing. We want to coalesce your accesses to global memory. Let me explain what that means. Whenever a thread on the GPU reads or writes global memory, it always accesses a large chunk of memory at once, even if that thread only needs to read or write a small subset of the data in that large chunk. But if other threads are making similar accesses at the same time, then the GPU can exploit that and reuse this larger chunk for all of the threads that are trying to access that memory. This means the GPU is at its most efficient when threads read or write contiguous global memory locations. We say such an access pattern is coalesced. In this example, every thread is reading or writing from a chunk of memory that's basically given by the index of the thread plus some offset. And so this is a coalesced access. This is good. You'll get very high performance on a memory read or memory write in this setting. In this example, every adjacent thread is accessing every other memory location. And so this is not coalesced. We would call this strided because there's a stride between every thread's access. And this pattern is not so good. If you think about it, the way that I drew this dotted line here sort of implied that the GPU in this case was accessing memory in chunks of 5 memory locations. So if I were to just draw out the next 5 memory locations, you could see that here, to service the needs of 4 threads making a request each to an adjacent memory location, I was able to service that with a single memory transaction, this dotted line. Whereas in this case, the same 4 threads are accessing a broader, or striding across memory, and I actually need to pull in 2 memory transactions, two of these chunks of memory in order to service that. So I'm going to get half of the speed out of my global memory here. You can probably see that the larger the stride between my threads, the more total memory transactions I'm going to have to do, and the lower my performance will get. At the limit, you can get to a place where each thread is accessing spots so far in memory or so unrelated to each other in memory that every single thread gets its own memory transaction. And this, as you can imagine, will lead to pretty bad performance from the memory system. So we'll talk more about memory optimizations later. So for now, just know that global memory is going to be fastest when successive threads read or write adjacent locations in a contiguous stretch of memory. Let's have a little quiz to explore this.